Welcome to the Explainer. You know those trigonometry problems that throw a massive angle at you, something way bigger than 360 degrees? It just feels impossible, right? Well, today, we're going to crack the code on those so-called impossible angles. And I promise, by the time we're done, you'll have a super simple toolkit to solve pretty much any of them.
All right, let's just dive right in with a problem that looks, well, a little nuts. I mean, what is tan of 570 degrees? You can't even picture an angle that big, can you? A full circle is only 360. It feels like a trick question, but trust me, there's a surprisingly simple secret to figuring this out.
So, to solve this, you can forget about your calculator. What we really need is a map and a secret code. First up, let's draw our map.
And here it is. Our map is the good old Cartesian coordinate system. It basically divides the entire world of angles into 4 distinct regions, or, as we call them, quadrants.
Okay, so think of it like this. Our journey always starts at 0 degrees right there on the positive x-axis, and we always travel counterclockwise. That first leg of the trip, from 0 to 90 degrees, that's Quadrant I. Then from 90 to 180, you're trekking through Quadrant II. The adventure continues into Quadrant III from 180 to 270, and finally, Quadrant IV takes us from 270 all the way back home to 360.
So you might be asking, why do we even care about these quadrants? Well, it all comes down to the signs, positive or negative. In that first quadrant, if you draw any right-angled triangle, its base is positive and its height is positive. And because of that, all the big trig functions, sine, cosine, and tangent, are all positive here. Simple enough, right?
But watch what happens as we keep moving around the circle. The second we cross over into Quadrant II, the triangle's base is now on the negative side of the x-axis. And if you go down into Quadrant III, suddenly both the base and the height are negative. This is the whole reason the signs of our functions start flipping around. So, how on earth do you remember which sign goes where?
Well, that brings us to our secret code. It's a really simple little memory trick that tells you exactly which functions are positive in each quadrant. You'll never have to guess again.
Just remember this one phrase, add sugar to coffee. Some people also like to use after school to college. Whatever works for you. The first letter of each of those words, that's our key.
So here's how that code works. The A from add is for Quadrant I, and it means all functions are positive. The S from sugar is for Quadrant II, meaning only sine is positive there. T from 2 is for Quadrant III, where only tan is positive. And finally, C for coffee is for Quadrant IV, where only cosine is positive. And that's it. That's the entire code for remembering the signs.
All right, so we've got our map, we've got our secret code. All we need now are the rules of travel. This is what I call the 90-degree multiple rule, and it is the last piece of this entire puzzle.
So the big idea here is that any angle, no matter how huge, can be broken down into a multiple of 90 degrees plus a smaller, much friendlier angle. And the key to this whole thing is whether that multiple, that little n in the formula, is an odd number or an even number.
And here is that final rule. It's actually really simple. If your multiple of 90 is odd, like 1 or 3 or 5, the function actually transforms. Sine flips to cosine, tangent flips to cotangent. But if the multiple is even, like 2, 4, or 6, absolutely nothing changes. The function stays exactly the same.
Okay, recap. We have our map, we have our code, and we have our rules. It's time to go back to that impossible problem and crack it wide open using our 3-step system. So, what is the value of tan 570 degrees? Let's apply the system. I think you'll be surprised how straightforward this is now.
Okay, let's just follow the steps. Step 1, let's break it down. 570 is just 90 times 6 with 30 left over. Step 2, find the quadrant. We go around the circle 6 90-degree chunks plus that extra 30. Now, since there are only 4 quadrants, we're just repeating the cycle. Going around 6 times is like going 1.5 full circles, and the extra 30 degrees drops us right into the third quadrant. Our code, add sugar to, tells us that tan is positive here. Step 3, check for a change. The multiple is 6. That's an even number, so no change. Tan stays tan. Step 4, put it all together. We have a positive tan of 30 degrees, which gives us our final answer, 1 over the square root of 3. See? Not so bad.
All right, let's do one more, but a little faster this time, just to see how powerful this system is. How about sine of 210 degrees?
Let's run the system again. Step 1, break it down. 210 degrees is just 90 times 2 plus 30. Step 2, where are we? Well, 2 times 90 is 180 degrees, and another 30 puts us squarely in the third quadrant. Now our code says t for tan is positive here, which means our sine value has to be negative. Step 3, check for a change. The multiple, 2, is even, so the function doesn't change. Sine stays sine. Step 4, so what do we have? A negative sine of 30 degrees, which is just negative 1/2. Simple.
You know, what we've really uncovered here is way more than just a math trick. It's a system for understanding cycles. This repeating pattern of quadrants, it's not just something on paper. It reflects the beautiful, cyclical nature of the world all around us, from ocean waves to sound waves to the orbits of planets. Now that you have this new lens, what other repeating patterns will you start to see? Thanks for joining this explainer.